For blood test number 5 in 2025, we saw that my biological age was 16 and a half years younger than the chronological, and if you missed that video, it'll be in the right corner. But does this biological age clock, PhenoAge, does it have blind spots? So to address that, let's take a look at its 9 component biomarkers. Now they include biomarkers of liver health and function, kidney, metabolic, immune, and also red blood cell related measures. But notably absent from this list are cardiovascular disease related biomarkers. And that's potentially important because cardiovascular disease is a top 5 cause of death. Now, a younger biological age using this clock is associated with a lower risk of death from cardiovascular disease. But I think it makes the most sense to not only track these 9 biomarkers and say my biological age is this or that, but to track biomarkers of cardiovascular disease risk and a whole bunch of other biomarkers that are related to optimizing organ and systemic function. So with that in mind, today we're going to do a deep dive into cardiovascular disease risk biomarkers. And that's what we'll see here on page 1 of the blood test report. And note that I don't go to my doctor to order these tests. I go to ultalabtest.com where I pick exactly the test that I want. I then bring this form to Quest Diagnostics, pay the about $10 blood draw fee, and then get the results relatively quickly. So we can see that I tested on July 22nd around 7 in the morning, and I had the majority of these results 4 days later. So if you're into blood testing like me and you'd like to help support the channel, you can do that by using the affiliate link in the video's description. All right, so on to the data, more specifically the lipid panel and starting off with HDL. Now, if we go based on the reference range, which is greater than 40 milligrams per deciliter, my value for the July 22nd test, which was 76 milligrams per deciliter, is good. Don't have to worry. But the Lustgarten optimal range is more strict. So with that in mind, what's optimal for HDL? So my range is 50 to 69 milligrams per deciliter. And this isn't my range for what my actual data shows over the past 20 years. This range, 50 to 69 milligrams per deciliter, is based on a study of, actually a meta-analysis of more than 3 million people and a separate study of 16 million people. But this is only part of the story because HDL declines during aging. And if you want to see those data, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers. It currently includes more than 2 hours of video content from 48 published references, and note that these aren't the reference ranges. This is what may be optimal based on how each of these biomarkers changes during aging and their association with all-cause mortality risk. So if you're interested in seeing those data, check it out. Now, the tier also includes the data for HDL. So let's take that a step further and let's look at all of my data as I have blood test values going back 20 years. And that's what we'll see here. So this is HDL from 2005 to 2025 as I have 73 tests over this 20-year span. So on the y-axis, we've got HDL plotted against age. Now, early on, pre-2015, we can see that HDL declined. And I wish I could say I knew what I was doing at that time, but I wasn't tracking diet or anything really. I was just going to the doctor once per year and recording that data into a spreadsheet. But then starting in 2015, I started tracking my diet using a food scale and then entering that into the diet tracking app Chronometer and then pulling that data into a spreadsheet. And then every blood test has a corresponding average dietary intake. And because each blood test has a corresponding average dietary intake, I started looking at correlations and following the correlations with the goal of improving biomarkers. And we can see that since I started that approach, I've been able to increase HDL in 2 spurts. The first one is shown in the green arrow, and then you can see that the slope of the second green arrow is even better. So in terms of that, what's optimal for HDL at 50 to 69 milligrams per deciliter, although my 76 is a bit higher than optimal, for the last 18 tests, HDL has been within that range on average, with an average of 58 milligrams per deciliter. So again, cumulative exposure, this is an important concept. Now, I can't undo all of the other data pre the last 18 tests, but the goal is to keep HDL in that 50 to 69 range and avoid any age-related decline going forward for all tests going forward. All right, so what about ApoA1? This is part of the story in terms of cardiovascular disease risk. Another includes ApoA1, which may be a better biomarker relative to HDL, but they may actually be about the same. Some studies show that they're the same, and there are studies that exist that show that ApoA1 is a better marker relative to HDL, which is somewhat surprising because HDL contains ApoA1. But note that ApoA1 isn't just contained within HDL, it can be freely floating in plasma. So that's a story for another day. So what's my ApoA1? And that's what we'll see here. For this test, it was 166 milligrams per deciliter. Now again, if we go based on the reference range, which is anything greater than 115 milligrams per deciliter, I'm good, don't have to worry. But note that the reference that they're using for their reference range is based on a study from 2004, and more specifically, this is the AMORIS study. Interestingly, in 2021, updated data from the AMORIS study was published. So 17 years later, there was more data for this study, and the range is actually different from what is shown here. So the reference range is slow to adapt to newly published data. Granted, it's 4 years old and it still hasn't been updated. Now, since then, there's also all-cause mortality data in a large epidemiological study. And again, these data, the pictures and video, all of that on Patreon, where all-cause mortality risk was evaluated in 2024 in association with ApoA1. Now, based on those two studies, my optimal range for ApoA1 is 150 to 180, as that's associated with lowest cardiovascular and lowest all-cause mortality risk. So based on this one test, 166, I'm good. But again, cumulative exposure, what does the data say for all tests? Now, I wish I could say I've been measuring ApoA1 for 20 years, but this is not true. I only recently started measuring it, so I only have 6 tests. But over those 6 tests, ApoA1's average is 146 milligrams per deciliter, which is just below that optimal range of 150 to 180. But when considering the most recent test was 166, I'm confident I can get it into the 150 to 180 and keep it there almost indefinitely. All right, moving on along, we've got next triglycerides, which were 62 milligrams per deciliter for this test. And again, if we go based on the reference range, which is anything less than 150, I should be good. And as a quick note that VLDL, so this is a lipoprotein focused video and lipoprotein related measures, VLDL, which is a lipoprotein, equals triglycerides, or approximately equals triglycerides divided by 5. So if we go based on the reference range, anything less than 150, I'm good. 62 is less than 150. But again, my optimal ranges are generally more strict relative to the reference range because I'm focused on studies in terms of age-related change and all-cause mortality risk. So with that in mind, lowest all-cause mortality risk in a meta-analysis for the association for all-cause mortality risk with triglycerides is anything lower than 90 milligrams per deciliter. So, okay, I'm good based on that. But then there's more data. And in another study of 4.5 million people, lowest coronary heart disease risk was associated with triglycerides less than 45 milligrams per deciliter. So based on that metric, my 62 is just outside of that. And my goal is to consistently get it down to 45 milligrams per deciliter or less. But this is only part of the story. Also note that triglycerides increase during aging. So it's, again, about getting one's data into the optimal range and resisting age-related change. So with that in mind, how well have I done or not since 2005? So the past 20 years, as I have 71 tests over that span, which is what we'll see here. And then on the y-axis, we've got triglycerides plotted against age on the x. So for the first 10 years, we can see that I was able to reduce triglycerides. And again, I can't say what I did back then because I wasn't tracking diet or actually anything, fitness metrics, sleep at that time. So it would be a rough guess. But what I can say is I was doing a lot more cardio back then, and that could be one reason. And to test that on the to-do list sooner rather than later, after I get fully settled here in Austin, is to add more cardio into my approach. And if that's true, I should expect to see my triglycerides come down. But before going to the last 10 years of data, note that I had 2 data points that look like outliers. And I think it's important to mention those. For the first, I went vegan. Now, this doesn't mean that vegan is going to raise your triglycerides, because also as a part of that approach, I was on a very low-fat diet. Now, not 10% of all calories, but relative to where I am now, about 40% of calories, it was around 20%. So this demonstrates that being on a lower fat diet, in my case, was not good for triglycerides. But then over the past 10 years, the data is not as good, even excluding those 2 data points around 90 milligrams per deciliter. We can see that the data is moving in the wrong direction for triglycerides, which increase during aging. On the other hand, if we look at my 71 test average, again, cumulative exposure over a long period of time, my triglyceride level is relatively low at 61 milligrams per deciliter as an average, still outside of that 45 milligram per deciliter amount that's associated with lowest risk for coronary heart disease. Now, it raises an interesting question, so if 60 is higher than 45 for 20 years, what would be my rate of heart disease progression if it was less than 45. Is that a 10% higher progression rate? Is that no progression rate? Is it, so nobody knows, right? So I think the safest bet, though, is to keep it below 45 indefinitely. So that's the plan. Can I do it? We'll find out. Stay tuned for those videos in future videos. All right, back to the report. So now we've got LDL, which for this test was 86 milligrams per deciliter. Starting again with the reference range, which is less than 100 milligrams per deciliter, I'm good. But then again, what's optimal for LDL? So in a study of 4.5 million people, lowest coronary heart disease risk was associated with LDL in the 65 to 120 range. And as a quick note, and I'm gonna give this idea its own video at some point, whether it may be on Patreon or on YouTube, but there is data out there that suggests higher LDL is better and lower LDL is worse, especially in very old people older than 80. And the long story short there is reverse causation. So LDL is lower in comorbid conditions like cancer, more specifically cancer cachexia. And some of these studies that show lower LDL is worse for survival don't adjust their models, don't account for this factor, cancer cachexia, impacting the association for LDL with all-cause mortality risk. Nonetheless, I'll do a deep dive into that topic in a future video. So in a study that accounted for comorbidities, more than 11 comorbidities, lowest coronary heart disease risk was 65 to 120. But in terms of the aging trend, note that LDL's trend during aging is an inverse U. So it's low in youth, it peaks in midlife, and then it starts to come down again towards advanced ages. So with that in mind, it can be hard to discern whether one's data is youthful or aged, especially when considering those comorbid conditions at advanced older ages. Nonetheless, what's my data? As I have 72 tests over the past 20 years, which is what we'll see here. On the y-axis, we've got LDL plotted against age on the x. And interestingly, we can see two inverse U's during my data. Increase, then decrease, and then another increase, and then another decrease. Now, pre-2015, I can't say what caused that increase and decrease. That actually may be aging. On the other hand, the last 10 years where I've tracked rigorously, I've done a whole bunch of diet changes. So my fat intake has ranged from about 60 to 120 grams per day, protein intake from about 70 to 150 grams per day. So I've varied my diet and even some supplements with the goal of impacting biomarkers so that I could have a wide enough range to evaluate correlations. So some of that up and then down for this LDL since 2015 is related to diet change. Now, along those lines, you can see that my LDL has been more stable more recently, and that's intentional. As with so much data, I'm finally settling on a diet that may be good for almost all biomarkers rather than having to try to figure out the diet that may be good for more biomarkers than not. So with that in mind, the plan is to keep LDL flat, avoid any age-related increase, and avoid any age-related decrease. Now, as a quick note, that 72 test average for LDL is 82.5 milligrams per deciliter, and if CHD progression is lowest around 65, I'm not too far from that. Now, there is another question inherent in this, which is 82 or 83 really different from 65 in terms of CHD progression? Nobody knows. I mean, you could make the argument that will lower ApoB, but even that story, as we'll see coming up in a bit, is maybe a bit more complicated because there are more atherogenic lipoproteins like lipoprotein A and VLDL that may impact ApoB levels relative to LDL. So at least in my case, but anyway, a story for another day. So next up is lipoprotein A. And now we can see that my data has been flagged by the lab, which for this test was 91 nanomolar. And if we go by the reference range, that's outside of that at 75 nanomolar, which then raises the question, what's optimal for lipoprotein A? Based on lowest coronary artery disease risk, less than 19 milligrams per deciliter or 48 nanomolar is associated with lowest risk. So there too, I'm not even close, 91 nanomolar versus 48 nanomolar. So this would suggest bad news. So what's my data? Is this just one data point or is this all data points going back for the past 20 years? So that's what we'll see here. I have 45 tests over the past 20 years. And unfortunately, lipoprotein A isn't measured on a standard chemistry panel, so it's an add-on test. So I have to add it on for every test relative to things like LDL or triglycerides or HDL. On the y-axis, we've got lipoprotein A plotted against age. So for the first 10 years, again, I was only testing about once per year, and that pre-25, pre-diet tracking average was 106 nanomolar. If you remember from the last slide, lowest coronary artery disease risk is associated with less than 48 nanomolar, so this is not even close, far away. This is terrible data. But note that I was able to have one data point that was pretty close to lowest risk, or at least on the borderline. But this was exogenously impacted, and I did that with very high dose nicotinic acid. So the flush, I got flushes at 200 milligrams per day. Imagine the flush at 2,000 to 3,000 milligrams per day. So that was exclusively caused back then by very high dose nicotinic acid. Now, one reason I stopped that is because it sent my liver enzymes close to 60, AST and ALT. So I'm not trying to reduce my risk of cardiovascular disease by taking a very high dose of nicotinic acid and then dying from liver disease. That doesn't make any sense. So if we take that data point out as a potential outlier because it was exclusively because of high dose nicotinic acid, that pre-2015 average is even worse, 112 nanomolar. But starting in 2015, as I started tracking diet and looking at correlations, I've been able to improve my average lipoprotein A over the past 10 years with an average of 90 nanomolar. Rather than just looking at these two groups of data and using a two-sample t-test, they are significantly different. So in other words, I've been able to significantly reduce my lipoprotein A over the past 10 years relative to the first 10 years. And I've done that exclusively by following diet. Now, on the other hand, you could say, all right, so you reduced it by 20%, big deal. 90 nanomolar is still far from 48 nanomolar. This is true. But there's a lot more to this story, or at least potentially a lot more to this story. And that's because high sensitivity c-reactive protein modifies the cardiovascular risk of lipoprotein A, which is what we'll start to see here. In this study, we've got the cumulative incidence of cardiovascular disease, CVD, plotted on the y-axis. In terms of what CVD included, it included heart attack, stroke, being diagnosed with coronary heart disease, having angina, or chest pain, having to be resuscitated after having a heart attack, or other atherosclerotic or cardiovascular disease-related death. And on the x-axis, we've got time. So then there are three groups. Lipoprotein A less than 50 milligrams per deciliter, and in terms of nanomolar, that's 125 nanomolar. So technically, I would be in that group, even though that's a relatively high amount of lipoprotein A. And then the other two lipoprotein A values, 50 to about 100, and then greater than 100 milligrams per deciliter. And these data are in people who had hsCRP greater than or equal to 2 milligrams per liter. What we can see is when compared with the lowest lipoprotein A containing group, that higher lipoprotein A and having higher hsCRP was significantly associated with an increased risk of having a cardiovascular disease event over that 18-year period. So these data show that having high lipoprotein A greater than 50 milligrams per deciliter and high hsCRP greater than 2 milligrams per liter is bad for having a CVD event. Now, based on these data, the question then is, what about less than 2 milligrams per liter? And also, what's my data? But that will be coming in a minute. So how does CVD risk look in people who had relatively low or high lipoprotein A and relatively low hsCRP, which is what we'll see here? And now, when compared with the lowest lipoprotein A containing group, although you can see that that red line has some separation from the two other lines, these values were not significantly different. So in other words, hsCRP modifies the cardiovascular risk of lipoprotein A, and in people who had low, medium, or high levels of lipoprotein A, as long as their hsCRP values are less than 2 milligrams per liter, CVD risk was approximately the same. All right, so now what's my data? Because my lipoprotein A is on the higher side, at least higher than the reference range. So what's my hsCRP? And that's what we'll see here. For this test, it was less than 0.2 milligrams per liter, not less than 2 milligrams per liter, but less than 0.2 milligrams per liter. But this is only one test. For the past 26 tests in a row, hsCRP has been less than the detection limit, which is 0.3 milligrams per liter. And for the most recent 10 tests, for whatever reason, Quest's limit of detection has been a bit lower at 0.2 milligrams per liter, and I've been at that level for all 10 of those tests. Now, taking it a step further, my 46 test average for hsCRP going back 20 years is 0.37 milligrams per liter with no test greater than 1 milligram per liter. So although my lipoprotein A is higher than the reference range, which would suggest a higher risk for coronary artery disease, that I've been able to keep my hs-CRP levels chronically low for this 20-year span over these 46 tests could be good news for helping to keep my cardiovascular disease risk relatively low. And that's potentially good news because my dad's father died at 67 of CVD-related issues. My dad's brother died of a stroke at 51. He had the stroke at 48. My mom's brother died at 67 of CVD-related issues and other stuff that ended up being comorbid. So avoiding death from cardiovascular disease is a top priority, in addition to living as long as I physically can. So in terms of the study that showed lowest coronary artery disease risk at less than 19 milligrams per deciliter and or 41 nanomolar, note that that study did not adjust their models for hs-CRP. So would that association still hold after accounting for hs-CRP? I don't know, but fortunately there are other studies that have looked at both hs-CRP and lipoprotein A in association with CVD risk. All right, so last but not least is ApoB, because with a relatively higher lipoprotein A, one would expect to have relatively high ApoB. Now, in terms of ApoB containing lipoproteins, they don't just contain lipoprotein A, but also VLDL, LDL, and IDL. Most blood test reports don't report IDL, so I don't have data for that. I can't talk about it. And you can see that on each of these lipoproteins, they contain the ApoB100 protein, or ApoB for short. In terms of what my data was for this test, ApoB was 71 milligrams per deciliter. If we go based on the reference range, which is less than 90, I'm good. But remember, my optimal ranges are generally more strict than the reference range, not because I want to be, but what's the most available data show in the largest studies, and the reference range is not always up to date on those studies. So with that in mind, lowest CVD and all-cause mortality risk in 2 studies combined, again, these data are on Patreon in the What's Optimal tier, is associated with less than 70 milligrams per deciliter for ApoB. So for this test, I'm just outside that, but not too far from that optimal range. But again, 1 test versus all tests. So what's my data over the 6 tests where I've measured ApoB? And again, I'm going to measure this for every test going forward so I can collect more data over time. As ApoB, it may be a better measure relative to looking at VLDL, LDL, and lipoprotein A individually. So my 6-test average is 67 milligrams per deciliter. So based on that optimal range of less than 70, I'm good. And again, the goal is to keep it there indefinitely, not have an age-related increase or even an age-related decrease. Now, this is just the beginning of this story. I've only shown 2 pages of the blood test report. There were 4 pages. So if you're interested in seeing that, it's on Patreon. And there's also more to this story because I haven't yet defined what diet, supplements, and prescription meds correspond to this test, where it was a 16.5-year younger biological age. So stay tuned for that. It'll either be next week or the week after that. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I offer blood test consults. And I also post at least twice per day in other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests done, the clearly filtered water filter, which I use every day, at-home metabolomics, we're up to test number 19, oral microbiome composition, NAD testing with Infinity, which I do at every blood test, epigenetic testing with True Diagnostic, at-home blood testing with Cyfox Health, which includes ConquerAging, the best epigenetic clock relative to epigenetic clocks. Whether they're better than other clocks, like PhenoAge, nobody's done that head-to-head matchup. But Cyfox Health includes ConquerAging, so if you're interested in that, check it out. Green tea, drink it every day. Diatractable chronometer, also using it every day. Or if you'd like to support the channel, you can do that with the website, Buy Me a Coffee. We've also got merch, including Data is my North Star, Figuring Stuff Out is my drug, and the channel theme, ConquerAging or Die Trying, which is what I've got on here. So if you're interested in that, link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.